Hello everyone. We're going to work through another example today. Here we have another divide and conquer type recurrence, and let's just jump right into it. We're going to do the exact same technique we've been using several times by now. We're going to plug whatever appears inside of t on the right hand side, which in this case is n over 2, back into the equation, which I've, again, like we've done every other time, designated with a red bar. So we plug n over 2 into the red barred equation, and we get t of n over 2 on the left is equal to 2 times t of n over 2, which is n over 4, plus cn over 2. We're now going to take that expression there, underlined in red, and replace t of n over 2 with it. So we have t of n is equal to 2 times the bit underlined in red, 2 t of n over 4 plus cn over 2 plus cn. Now maybe we do a bit of algebra here to see if we get any nice simplifications. We get t of n equals 4 t of n over 4 plus 2cn over 2 gives us cn plus cn. We can maybe group together those last two terms and have t of n equals 4 t of n over 4 plus 2cn. Now, we take whatever appears on the right-hand side in our new equation here, which is n over 4, and plug it back into the original. So plug n over 4 into the red barred equation. The left-hand side would be t of n over 4 is equal to 2 t of n over 4 over 2, which is n over 8, plus cn over 4. We're now going to substitute that right-hand side, 2t n over 8 plus cn over 4, in for t of n over 4. Doing so, we have t of n equals 4 times the thing I've underlined in blue there, 2t of n over 8 plus cn over 4 plus 2cn still from the original equation there. Now distribute the 4 and let's see what happens. We get t of n is equal to 8 t of n over 8 plus 4 times cn over 4 is just cn plus 2cn, and just like we did before, let's group together those last couple of terms. T of n equals 8 t of n over 8 plus 3cn. So, we've done a couple of substitutions, now we need to identify a pattern. The t stuff actually isn't too bad. We have 8tn over 8, 4tn over 4, and 2tn over 2. That looks like powers of 2. So maybe we go, that looks like 2 to the k times t of n over 2 to the k. For the other term, the 3cn, the 2cn, and the 1cn, those match up really nicely. 8 is 2 cubed, 4 is 2 squared, and 2 is 2 to the 1. So this looks like k times c times n. So we've identified a pattern here. So let's write that down. For any value of k, we have t of n equals 2 to the k times t of n over 2 to the k plus k times c times n. So we want to find out when does this terminate, so it stops when the thing inside of t, which is n over 2 to the k, is equal to our base case. What's our base case? Well, if we scroll up, it was t of 1 is equal to c. So we need to set n over 2 to the k equal to 1 and solve for k. Skipping a bit of the algebra, that's k is equal to log base 2 of n. Multiply by 2 to the k, take a log base 2 of both sides. We're going to substitute that back into our generic expression there and have t of n is equal to 2 to the log base 2 of n times t of 1. I know it's t of 1 because n over 2 to the k equals 1. Plus k, which is log base 2 of n, times c times n. And conveniently, t of 1 is just c, and there's actually very little work left to do. We just need to identify sort of the complexity of the terms we have involved. Conveniently, 2 to the log 2 of n, those are inverse functions of each other, so they cancel. So we have cn plus that last term, maybe I write as cn log base 2 of n. And the dominant term here should be n log n, so the complexity, therefore, is t of n is in theta of n log n, which is not too bad to actually work through this problem. The one thing we need to be careful of is when we have a coefficient in front of t, you need to be careful with your constants, because losing track of them can make you get the wrong pattern and therefore get the wrong complexity. So always be careful in this substitution step here, and do not skip too many steps. But for a problem like this, thankfully, not too bad.